Alright, I'm going to show that these four elements span R3. These four span R3. I'm going to do this in 2 steps, or split screen. Here's what my answer is going to look like, and here's going to be some scratch work. So here's what's going to happen. I need to show that this set spans R3. That means for any element of R3, I should be able to write as a linear combination of these 4 things. To show that that's true, I need to pick any element of R3. So I'm going to pick a completely generic element of R3. So what I'm doing is, as I'm setting the ground rules here, I need to show that A, B, C, where A, B, and C could be anything, it can be written as a linear combination of those 4 things. So I think of A, B, and C as constant. That is, I can't make any assumptions about them. I can't assume that B is an integer. I can't assume that C is negative or positive. They just are what they are. They could change from problem to problem. What I'm doing here is I'm doing an infinite number of proofs at once. I'm proving when it's 0, 0, 0. I'm proving when it's 1, 1, 1. I'm proving when it's pi squared root of 2e. I'm proving when it's pi squared root of 2 negative e. And the proof will be the same. It's just plug in whatever the variable is. So I'm just doing it once, but I'm doing it very abstractly. What I'm going to do is I'm going to write this as w times the first element here, plus x times the second one, plus y times plus z times 1, 1, 1. If this thing is to be a linear combination of those, it has to be a linear combination of those. So I have w, x, y, and z. So I'm going to tell you what w, x, y, and z should be such that these things sum together to give me a, b, and c. Now, I can't change what a, b, and c are. On the other hand, that means I'm perfectly happy if I get, for instance, that w is equal to a plus b plus 2c. Right? So I can solve in terms of a, b, and c. So I'm going to do that. Maybe I'll combine these into one element. So I get w in the first component there, 0 in the first component there, y in the first component there, and z in the first component there. Get 0 in the second component, 2x in the second component there, negative y in the second component there, and z component there. Finally get w plus 0 plus 0 plus z. That gives me 3 equations. I have a is equal to w plus y plus z. I get that b is equal to the second component here, 2x minus y plus z. And I get that c is equal to w plus c. And I notice that I have 4 equations, or 4 variables, and only 3 equations. That means that I might have some leeway, which means I'm going to try setting w equal to 0. Why can I do that? To be honest, I'm not sure that I can right now. But I have more variables than I have equations, which means I have a chance of being able to simplify things by picking one. Remember, I just need to show that this thing spans R3. In other words, I need to be able to show that this can be written in as a linear combination of these 4 elements. I don't really care what linear combination, so sure, pick one to be 0 if it's convenient to you. I think it might be convenient to me, so I'm going to do that. When w is equal to 0, that disappears. I get b is equal to 2x minus y plus c. No help there. But here, I get that c is equal to w. C is equal to z, sorry. In other words, if w is equal to 0, I know what z is. I know it should go here. C should go in front of there. Because remember, c I'm pretending is a constant. That gives me that a is equal to y plus c. And that gives me that b is equal to 2x minus y plus c. And look, that gives me that a minus c is equal to y. In other words, y is equal to a minus c, and these are both constants as far as I'm concerned. So now I can just plug in here. I get b is equal to 2x minus a minus c plus c. In other words, I get that 2x is equal to b minus c plus a minus c, because there's a minus sign there. So I get that 2x is equal to a plus b minus 2c, and x is equal to 1 half a plus 1 half b minus c. So what happens here, right? The way you think about this is pick any a, b, and c that you want. If you pick 1, 2, 3, I'm going to tell you fine. W is going to be 0. X is going to be 1 half times 1 plus 1 half times 2 minus 3. And y is going to be 1 minus 3. And z is going to be 3. And that's what the coefficient should be. Oh, you don't want 1, 2, 3? You want 1, 2, negative 3? W is going to be 0. x is going to be 1/2 times 1 plus 1/2 times 2 minus -3. Y is going to be 1 minus -3, and c is going to be -3. You tell me what these numbers should be. I'm going to tell you what the coefficients are in response. And then here's what we do. Then w times the first one, w I'm going to let it to be 0, plus x times the second one, but I know what x is. I want x to be 1/2 a plus 1/2 b minus c, plus y is going to be a minus c times 1, -1, 0, because that's what y goes with, plus z is equal to c times 1, 1, 1. That's going to be equal to, this just goes away. If I distribute this through, I'm going, well, let's just do this in step by step. This times 2 goes in the second component, so that gives me a plus b minus 2c, and then anything times 0 gives me 0, plus a minus c goes there, minus a minus c is c minus a, 0, plus c, c, c. Combine this into one thing, and I end up with 0 plus a minus c, plus c is in the first component, 0, a minus c, c. Now I get a plus b minus 2c plus c minus a plus c. And the last component, I'm going to get 0 plus 0 plus c. So I'm liking the way the last one looks. What do I get? I get 0 plus, a minus c plus c just gives me a. That's good because I want it to be a. I want the next one to be b. I get a, I want the next one to be b, sorry. I get a minus a. I get -2c plus c plus c, so that just leaves me with b, and I'm just left with c right there. So A, B, and C belongs to the span of 101, 020, 1, -1, 0, 1, 1, 1. So this set spans R3. Again, the idea is you tell me any numbers you want for A, B, and C. So you're allowed to pick anything for A, B, and C. In other words, this could be literally any vector in R3. You tell me what those elements are, what those numbers are, I can combine them into what the coefficients should be. That's a C. That's not parentheses. So you tell me what they are. I'm just going to make a formula for all the four coefficients: 0, 1/2 a plus 1/2 b minus c, a minus c, and c. And then no matter what they are, they're going to cancel out so that you're left with a, b, and c. So that means that any element, no matter what you pick, I'm going to use those numbers against you to get coefficients so that they're in the span. So that means that any element is in the span of this, which means that the set spans the entire thing. Thank you, that is all.